Yesterday, we were taking a walk in the city, and I found this beautiful postcard that I would like to send to my family, to my mother. It's not a very beautiful postcard, really. Somebody gave me another more beautiful postcard, but I already write the message, and I have to admit I don't have very beautiful handwriting. But it's okay, it's very convenient, because today I'm going to talk about an optical character recognition system for handwriting that I developed some time ago. As Daria told you, my name is Diana Ortega. I am a software developer at Xivia, and I am also the organizer of the Women Who Go meetup in Paris. Well, some time ago, we had a client I was working for, and they had a huge database of photos with images of documents filled by hand. It was some kind of vouchers or things like that, and they wanted to automate the extraction of the data of these photos and save the text inside a document database. That's an optical optical character recognition system. We test a lot of systems, and there are a lot of in the market, but we wanted something more specific to the context of the client. Maybe plate numbers, name of people, or something like that. So we decided to develop our own system using deep learning. And we talk about deep learning, we are talking about neural networks. Deep learning is a part of machine learning. And what is machine learning? Sorry, I'm spoiling. Machine learning is the ability of a system to acquire their own knowledge. When we talk about that, we talk about, some people think about the machine wars or something like that, Terminator, something like that. But we can express machine learning like just to tell to code the rules, all the rules that describe a system. For example, for handwriting, if we have 4 font types like this one, it would be easy to recognize handwriting and text coming from these fonts, and because we have a limited set of rules. But with handwriting, it's different. We don't have a limited set of rules. We had a lot of variation. And I think that we have as many fonts as people in the earth. We have different characters. We have different color of the background. We have, as they are photos, we have different resolutions. And we have some characters or some things that doesn't belong to any alphabet, but they are there in the photo, in the image. Maybe like that. It's not really straight. Sorry. Okay. So we have a large variability. And we have a large variability. We would like the system to learn by itself all this variability from examples. And that's machine learning. So we have to find something that can express from some inputs with some parameters and outputs that I know. And what's that? A function. So I have to find that function that the machine is going to recognize to express the system. And all of us, we are experts in machine learning. And I'm going to demonstrate it with a trivial example. This is a table. I have a register for some distance, the time it took me to hike this, to walk this distance. I take all those data, I put them in a graph with some points, and I trace a line that is the closest line to all of these points. This is a linear regression. So for tomorrow, I'm thinking about having a walk between the botanical garden and the National Library. It's about 6 kilometers, I think. And how many time is going to take me? Well, it's 6 kilometers more or less this. So I trace a line over here, and it takes more or less 100 and something, 120 minutes. And as I say, we all know how to do this thing, and so we are all experts in machine learning. How do you do a real machine learning project? There are a lot of steps. We have, first of all, to identify the problem. Then we have to explore and select the data. We have to gather data. We have to clean the data, profile the data. Then we can start thinking about creating a model. A model is to find this function I told you before. And we have to prepare the data. I have to define the model. Then I code the model and train the model, and I test the model. And we have a model, the function, and the parameters. We can deploy and industrialize all of that. That means that for machine learning code, for a machine learning project, I have a lot of code to do. But the real machine learning code is in this proportion. This red box represents the proportion of the machine learning code in a machine learning project. As you see, it's a very small box. That means that maybe data scientists and data engineers don't have as many fun as we think. So I developed, when I had to develop this project, I did it using Python, Java, Tensorflow. But let's move to a universe where I'm using only Go. What happens? Well, I already identified the problem. Let's start exploring and select data. Okay, I select the data. I select a database of handwriting because I need some examples to tell the machine how it's going to work. I select a database of handwriting characters that is called the IAM database. We have a lot of words, text. You can see there are different kinds of text. It's well annotated. It means that we have text in clear that identifies an image, and all the text is inside the image. And we have a controlled variability. We have black over white. So I have the data, and I have a lot of libraries, and very particular library that I like a lot because it's very powerful is GNOME, that allows me to trade the data, to handle data as it was like think about an Excel. It's just a data frame. You can handle data in columns. So you can use that for looking your data, for cleaning your data. And there is a tool that is called a notebook that is very used by data scientists that allows them to see the data and to test some things before developing a real model. You can use one of the most popular notebooks is Jupyter, and you can use Jupyter with Go. Okay, I explored my data, and I found that I can use Go tools to do that. That's good. Let's pass to the train and test model. Well, as I said before, we have to find a function and parameters that translate this photo to this text. It's easy, no? Well, it's not that easy. We found a paper from this person, and it was the state of the art at the time. And it's not one function, but three. It's 3 neural networks connected. The first neural network we call CNN, and it's popular because it's the tip of architecture of neural networks that allows you to classify photos, for example, photos of cats and dogs. But instead of detecting if it's a cat or a dog, we are going to pass the output of this neural network to another neural network that is a more complex has a more complex architecture that is a recurrent neural network, and we are going to call it the encoder. And the output is going to pass to another neural network that has a similar architecture, and we are going to call that the decoder. So let's try to implement that in Go. As I used in the previous version of the project TensorFlow, I wanted to use TensorFlow with Go in this project. TensorFlow is a library for machine learning. It uses a graph-based flow, and maybe it's one of the most popular frameworks in the market. Sorry. The graph-based flow, it means that when you are programming, you create a graph where the nodes are the operations, for example, on convolution or something like that, and the tensor are the data. Then you create a session and you create the model that allows you to create the model. When I was looking for the libraries for Go and TensorFlow, you go to the website and you find this disclaimer. These APIs are particularly well suited to load models created in Python and execute them within a Go application. Okay, it's not cool, but I'm a rebel, so I'm going to try. The first thing I do is in my Go modules, I import a TensorFlow, and I have the last version of the libraries for TensorFlow 1.14. It means we are working with the TensorFlow 1 something. TensorFlow is now, we are talking in TensorFlow about TensorFlow do something. So, but it's okay, it should work. I try to implement the first part of my model. It means the CNN. And yeah, I can have the operations. I say convolution is like the convolution of two matrices. It's a mathematical operation. And I have a pooling that is like an subsampling. I can reshape the matrix, for example, and I can have some operations for comparing if what I want and what I get are similar or not. But there is a problem. The only optimizer that is this one that allows me to see that is implemented for the Go API is this one. It's okay, but I don't want that. I want another one that is more maybe powerful for me. No, there is not, and if I want it, I have to develop it from scratch, and I don't want to. I'm not a very mathematical person. So I say, okay, it's not that simple. You can create a graph with Go, but it's complicated. You don't have everything in the API, and if you want to have some things, you have to develop it from scratch. But if I have to develop it, maybe I can use something more Go. And yeah, sorry, I have a problem with this pointer. Yeah. If I have to develop from scratch, why not use a native Go library? Well, we have a very good library for doing machine learning that is Gorgonia. It's similar at Tiano in Python for those that use it to Python. It works with graphs like TensorFlow. I can create tensors and graphs and all of this stuff, and support many Go versions. So let's give a try. As I say, I have a graph. I can initialize a graph. I can create tensors. Tensors are like an array. Sorry about that. And we can have tensors of different size and shapes. This is okay. This works for me. When I did all of those things in TensorFlow with Python, I had these two lines of code. And I have here like 1, 2, 3 lines of code in Go. I have the convolution, the activation function, and another sampling function. But that works for me. And that's how I create my CNN. I can classify things using Gorgonia. And that's a very good point. But the output of my CNN is the input for my encoder. So let's try to create the encoder. When I did it in TensorFlow, it's like I have to create a cell that is a subfunction that is going to pass to the neural network. But I use it not a unidirectional, but a bidirectional RNN. So it's more complicated. I'm going to try to do the same thing in Go, in Gorgonia. And I couldn't. I couldn't find an LSTM, the basic function to create my architecture for the neural network. There has been some people that have tried, but more like a side project. And well, sometimes they arrive, but they did it, but the performance is not very good. So if you want to develop that, only do it under the consent of a responsible data scientist. So I couldn't implement the recurrent neural network, so I don't have encoder and I don't have decoder. Someday, yeah, it's so sad. I wanted to develop everything in Go, but I couldn't do it. If I want to create the neural network, I have to create my recurrent neural network, and this is the formula of a small part, because I need as well the activation function that is something a little more complicated. I'm crying. It's not good. But for other type of projects, like for classification, k-means, linear regressions, Gorgonia and GNOME are very, very powerful tools. And they are developed for the community. Well, I don't have a model created in Go, but maybe I already have a model created in Python. Maybe I can use it to deploy and use it using Go. Let's try. Well, there are a lot of frameworks in the market for doing machine learning. This picture is from 2017. There has been some changes, but it's still available today. They joined effort to create an open neural network exchange framework in interoperability. It's called ONNX. It means that you can create a model using any of those frameworks. You can export it using this framework, and you can create interoperability for use this model in wherever you want. And actually, there is an effort to implement this ONNX Go and include it in the Gorgonia libraries. It's a work in process. Sorry. And if you want to collaborate, it's a good opportunity. As I said before, I use TensorFlow, and TensorFlow has already their API bindings. So I'm going to use TensorFlow bindings. To do that, I created my model using Python. In Go, I have to create a session, load the model, and run it to get my answer. It's important to save the model and give name to your tensor. It's because it's easier for you. Like that, you can create a model and give the graph and variable and save the variables in Python. And here, you can save the model. You can put the inputs in your inputs variable, and you can call the output and have the answer after running the model. If you don't name your tensor, you can go and take a look at what the model looks like, what are the names of the variables using, for example, a tensor board, or with Python, or with Go. Sometimes you get errors like this one, but you get used and you learn how to debug your implementation. But there are some things, basic things, that they are not implemented in Go. But if you want to do it, it's a good opportunity for contribute to the open source. Well, I tell you about this postcard that I wanted to send to my mother. I started to write something like that. As you see, this postcard has some background in it, I don't know. And my handwriting is horrible, sorry. I'm going to try to see what happens with my model, trying to translate that. I tried just with the word Minsk, and I didn't find anything. Maybe it's because of the background. I didn't have time to clean my image, and that's why it's important, the first step of the pipeline, to clean the data. But if I use some other examples that I have in my data set of my database of example, I didn't train my network with this image, but I use it to know if it works, and it works. And I'm showing you here some edge cases. For example, here it's supposed to be asked, and he understood that, execute. This is easier, cost, households, handholds, substantiate, yeah, and cult. I don't know if you can do it better. For deploying the model, you already have your code that uploads your model and do the things you want to do. But for deploying, you can use, for example, Docker, containerize your code. You can create your own pipeline using create your event-driven application, or use something like Pachyderm. That way, you can industrialize your model. For monitoring, you can use everything you want. You can monitor everything you want. You can use the GoTrace to trace what happens inside your code. You can export some metrics and read it in Grafana and something like that. Actually, it's not bad. Well, in conclusion, there are a lot of tools for data science. We have GNOME, we have Gorgonia, we have Jupyter notebooks. We are creating Onyx for Go, and there are the official TensorFlow bindings for Go. We have Pachyderm, and there are a lot of things you can do, and you can start contributing. We have also the Slack channel for data science. Yeah, it's an invitation for start contributing to this passion and kind of project. As a conclusion, if you are using the existing TensorFlow models, you can use the official bindings of TensorFlow for Go consume your models. You can also use a project that is called TFGo, that is a version of the API for TensorFlow. If you want to develop from scratch, you can use Gorgonia, GNOME. But if you want to not to think a lot and have all of the support of the community, the libraries with Python are more mature in this sense. If you are creating a model that is not a neural network, you can use Go libraries, but they are still in development. Things are getting better. Sorry. I saw this tweet some time ago. It was from Boulangerie in London. And those are croissants, charcoal-activated vegan croissant. It doesn't look very good, but here it says tastes better than it looks. I think it's the same with data science with Go. Thank you.
Thank you, Diana. Any questions?
Hi, thank you very much. I have one question. How do you test your model? I mean, it's hard even for a human to recognize sometimes.
Yeah. Actually, when you are training your model, you have you know what you want. So you have to establish some metric to see what is the difference between what you get and what you want. For example, for training this model, I use the Levenshtein's distance. That is if we have a word, for example, home and hall, the distance, the Levenshtein's distance is 1 because it's just a character different.
What if you cannot recognize the initial? What if you cannot recognize? I mean, the initial value. Somebody just wrote something and you cannot recognize it. It's like
with this kind, this is because it's a supervised model. Because I have to control the data set, the examples where which I am training my model. So this is important that the data set is well annotated, and that's why I know what is really in the text.
Thank you.
More questions? No questions? So thank you, Diana.
Thank you.